Hello friends, welcome to our channel. So let's have a look at problem 2415. This is a daily challenge problem. So basically the requirement is to reverse odd levels of a binary tree. So for example here you have this is the zeroth level, first level, right? The third level. This is the second level because we are using this is 0, this is 1, this is 2. So for 3 and 5, we're going to reverse that. So this is a 3-level tree. So here we have a 2-level tree. So because this is an odd level, so we're going to reverse that. So notice that tree data structure is a recursive data structure. So we needed to do this, also in a recursive fashion. For example, if we have another level down below this this level 2, so then we will need reverse all the node values in that level. So here we can imagine, in order to make this problem, we make sure that we understand this problem correctly. First, so here the tree is a complete tree. This is a very important assumption. Yeah. Right. So another thing is that how do we do the reverse? So for example, let's assume. So this is just assume, right? Assume that this level 8, 13, 21, and 43 is an odd level. So just to fix the idea, because in this problem, the level index for this row is actually 2, is not odd level. But if it were odd level, so the reversed node should have value 30, 34, and 21, 13, and 8, right? So this is important for us to write solutions if we want to use recursion, because this is the correct order after reverse. So with that said, I guess we are ready to do the problem. So during this video, we are going to give two formats of solutions. So the first format will be based on level order traversal. This is very natural, right? Because we want to reverse a specific level. In this problem is odd levels. So if we can get all those levels and the corresponding nodes, then we can do the reverse. And then the second solution will be based on recursion. The reason is also natural because tree is in particular a recursive data structure. So I'm going to look at the first solution. The first solution is recursive one. It's iterative one. Iterative. So the basic idea for this one is that I get all the nodes, and then we just do some reassignment. So first I can get this node. So the first row is like this, and then the second row, because second row the indexing number is 1. So I'm going to reverse all those nodes. I'm going to get this 5 and 3, and the third one actually just 8, 13, 21, 21, and 34. So because this level is level 0, this is level 1, and then this is level 2. Then we do reassignment, because then this is the first node, 0th node. Then the child will correspond to the next level, the 0th, right? So the left, so 2 left actually is 5. So we set it to 5, and 2 right, we're going to set it to be 3. But how do we get those? So actually it's very easy, because here we are using 0 indexing. So when you're at a level, right, so assume you are in level I, so corresponding to the row index, right, so the row 0, row 1, and row 2. Then you have a jth node in that level. Then the 2 child for this one is nothing but, so at level I, the jth node, the 2 child is nothing but next level, right? Then it's 2 times g. Another one will be 2 times g plus 1. So for example, 2 will have, this is the 0, 0, right? It's corresponding to 1, 0, that is the 5. And then the right node will be 1, 2 times 0 plus 1, that's 1, 1. So similarly, because we don't need to reassign for this, but you can also retrieve, for example, 3 the two nodes are 21 and 32. So because 3 is corresponding to 1 element, right? 1 then the two child node will be 2 and plus 1, then 2 times 1 plus 1, that is 2 3. That is 2 and 2, this one, and 3, this one. That's actually the main idea for this solution. This is a super routine, so it's a level order traversal. So from the standard level of traversal, you get all these levels, then you just do reassignment. Let me change this function signatures. So let's first code this way, and then we do the recursion solution. So for this, first I'm going to get the nodes. So I'm call this a list to hold the different levels. Then the current level should be the root. Let's check the assumption, because we have at least 1 node. In other words, the original root is not null, right? Then also we know for this row, the level index will be 0, right? Then we are going to do the basic while loop for level order traversal. So then first, if level index, so modulo 2 is not 0, in other words, it's odd level, then what we want to do, we need to reverse this level, right? The current level. So what we are going to do, nodes, we append that level, the list corresponds to that level, but also we need to reverse. So this is this basically standard operation, right? So now once we have this, the else block is rather straightforward. We just need to directly nodes append the level. We don't need the reverse. And then what should we do? We need to update the level, right? A basic list comprehension. So we get the child for each level. So for node in level, for child in node left, node right. So notice the order is important. So if child is not null, right? So once we get this, we are going to increment the level index by 1, right? So in other words, this increment operation actually switch between even and odd levels. So once we have this part, and then we can do reassignment. So this is also essentially repointing, right? Repointing to the correct nodes. So because we have already done the reversal, then we just need to do a for loop. So for I in range, so length of this nodes. So this is the number of levels, but for last level we don't use reassignment, right? And then so for j in range, length of the current level nodes I. What we shall do? So nodes, so i's level, the j's child. The left will be nodes I plus 1 and 2 times j. So because here I'm using 0 indexing. So let's copy this part. So for the same node, but it's right child. So we're going to increment this by 1. And then what we want to do is to return the root, that is nodes at 0th level and 0. So this is the one solution. Basically, we use level order traversal. This method is very natural, and also it's helpful for digestion, right? So now let's do a test. It's not right. Let's see, where's the problem? So here, nodes, level, we have level index. So yeah, if level index modulo 2 is 0, then if it's 0, so here actually if it's 0, we don't reverse. So here we reverse. Let's check again. Yeah, it passes the first example. Now let's quickly check example 2. Yeah, it passes example 2 also. Now let's look at the generic case. Yeah, it passes all the cases. So now, I guess this is a standard practice for level order traversal. But you know, for a tree data structure, it's a recursive data structure. Let me also write a recursion solution. So for this, I want to come back to here. So we need to reverse the whole level, right? So that's actually give us a hint on how to write the recursive function. So what we want to do actually is to copy this function signature first. And then I'm going to change this one to be version v1, and then we test this one. So here I'm going to use recursion. So because we have used the level order traversal to digest the problem statement, so for now we can write a recursive solution. So I'm going to overall, what I'm going to do is to first write a worker function, write a worker function to do the job, to do the operations, and then we call it, right? Call this function and do return. So for this one, actually, we need to use a slightly different function signature than the major function. What I want to do is I write a worker function. So I accept two nodes, nodes 1, node 2, and we need to have the level information, right? Because if it were odd level, so we need to revert, right? So first, if not node 1 or not node 2. Actually, we can just write 1 because we always make a same level, and the tree is also a complete tree. That's why we see this is a very important assumption. Especially this assumption enables us to write a solution like all level order traversal in the current format, right? So if this is empty, we just return, right? And otherwise, so what do we want to do? So we check the level. If level modulo 2 not equals to 0, in other words, it equals to 1, then we need to change the value. Node 1 value and node 2 value. We're going to switch node 2 value and node 1 value. In Python, you can do like this. If in other languages, you can introduce a temporary variable and then do the switch. So this is the one. Once if it were indexing even level, so we don't need to do this this one. But the next two lines are very important. So what we do, we call the worker, right? So for example, if this were 8, 13, 21, and 34, if it were a odd level, we want 32 switch with 8, right? In other words, this is the left child and this is the right child. What we do actually is call node 1 left to the very left and node 2 to the very right, and then the level is incremented by 1. So we also need to do for the middle ones. So it's actually worker node 1. So move towards the inside, that is right. And node 2, we're going to move towards the left side, then level +1. So this is the right function call, self-call for this specific problem given the requirement. So this is a major hyperfunction of worker. So what we do, we just need to call the worker. So for the call the worker, because the node is not empty at default, right? So we need to call it for root left and root right. So for this level, so their level indexing is 1, so we need to write 1, right? So then what we do is we're going to return return the root after we modify this. So this is the recursion solution. Let's do a test. So it passes the example 2 because we have already tested the recursive format. We had a good understanding about the problem statement, about the problem assumption, so we can directly test this. Yeah, it passes all the cases. Here, actually, I can see this. So if you call making this call, this is for sure right. Let me copy that and let me make a different call. So I can also call the root, right? So root, and then the root. Then, but here I use level 0, right? Let's test that. Oh, this is not right. So here you can think why. Because if it's just a root itself, so for example, here we have root and level 0. So it's for sure we do not enter this this if block, and then we test that. We also not enter this one. Then we call root left and the root right, right? So and then level 1. So then also we call root root right and root left. Then this actually, so this call lead to, so let me write. So this will lead to a call for worker. So because it not enter this one, it also not enter this one at the very beginning. It's going to call root left, root right, and 1. But this line of code will call what? This call worker, root right, and the root left, and then also 1, right? Then you switched, and then you switch back. For sure, you do not get the right solution. So let me comment out this one. This way of function call is not right. So that's why we start from here. So we call root left and root right. This is our starting, right? And so we get this passed. So this actually is an important point. So because here, when you write recursion, you need to pay attention to the base case or to the stop condition or the bounding condition. So with that said, I guess we finished the second version, the recursion solution. And also we point out a dedicated point we need to pay attention to. So with that said, I guess we covered the 2 versions of solutions. Let me give a quick summary. First, in this problem, so the assumption is very important. Here we are dealing with a complete tree. And then because of the problem requirement for reverse odd levels, so we first did a level order traversal. So this method is very routine. And then the overall requirement is that you can do tree traversal. It's here level order traversal. Then you know how to, according to the index, you get the correct children. So that's the first one. In the second one, we write a recursive solution format. Here I write a worker function to do the job for us. And in between, actually, some people might think when we do recursive coding, so there are 3 cases, right? There are 3 ingredients. So one is base case or boundary conditions. The second is that working towards the base case by a recursive call. Third one is the proper return. So in this case, I point out that the base case or the way you call the recursive function is also not trivial, right? So that's the second part. With that said, I guess I finished the summary. So thank you for watching.